Good afternoon, everyone. My name is Kushal Shah, one of the authors for the research paper titled Timeframe Analysis for Sentiment Prediction of Stock Based on Financial News Using Natural Language Processing. Next, we move to the content. So, these are the topics which we will cover in today's presentation. Starting from the abstract, through this research work and our study, we propose to use BOT, which stands for Bidirectional Encoder Representation Form, as a data preprocessing model used to analyze and calculate sentiment over text or news-based data. In this study, we have highlighted a use case wherein a proposed model has proven to give better result as compared to other models used in the past. So for the use case of identifying an impact of a news to a particular stock and its price in the stock market has been studied by identifying the investor sentiment from that news over various time frames. As a part of study, we have also focused on providing a comparative study of various NLP-based machine learning models that are naive-based recurrent neural networks with gated recurrent units, bidirectional long short-term memory, and RNN LSTM for news-based data processing over BERT technology, with bidirectional LSTM giving better results of over 90% for the Indian financial news dataset, with news extracted from various sources such as Economic Times, Money Control, Life Mint, Business Today, New York Times, and Washington Post. Starting with the introduction, as we all know, the stock market is a complex ecosystem where investors can buy or sell shares of different companies. The sentiment of investors and companies, as well as the sentiment of news, have a direct impact on the price. Therefore, analyzing the sentiments can help to know the market trend. An estimated future price or sentiment will help these investors to get more convincing results. Different supervised models of machine learning and deep learning have been developed for stock market analysis. However, achieving a higher model accuracy is still difficult. This is where a proposed method comes into play. Our method integrates recurrent neural network with bidirectional long short-term memory to determine the impact of news sentiment on stock market fluctuation and improving the accuracy of volatile stock trend predictions. In order to help investors identify news-based fundamentally good stocks, we have built a web application where investors can get insight on various Indian stock companies. The analysis of a particular stock can be viewed and filtered using the time frame provided by the user. The application offers a comparison between the stock companies as it provides the status of each news, that is a positive or a negative news, with a confidence value that can range from -1 to 1, and the mean confidence between them for each stock company listed. The proposed application also shows analysis of news sentiments for a stock and its impact over different time frames. By using a method and web application, investors can make more informed decisions about their stock investments and achieve better results. So we move on to our survey. We have done an extensive survey of previous research in the field of news-based sentiment analysis that has been analyzed before working on the implementation of our proposed model. It has been found that current sentiment analysis technique using natural language processing are not entirely reliable, as they have an accuracy of less than 80%. To improve this, we have a proposed model using BOT data processing technique with an LSTM model. Majority of the studies referred used the Reddit headlines on Dow Jones Industrial Average of the US-based stock market to measure sentiment analysis of a news. Whereas in our work, we have made it a point to use Indian financial news dataset in order to provide news-based sentiment analysis for multiple timeframes to Indian investors. Furthermore, we have also looked into research on predicting stock index movement for different timeframes, such as study by Yubo, B, H. Liu, R. Wang, and Shio Li. They focused on developing a correlation between index movement and general daily world news to predict stock index movement for different time frames. Our research takes a similar approach, grouping news data into time frames of 30, 60, 90, and 180 days to analyze the pattern of stock price movement using LSTM. In conclusion, our proposed model using BOT data processing technique with an LSTM model has the potential to significantly improve the accuracy of sentiment analysis of financial news for a particular stock. This can aid investors in making better investment decisions in the stock market. Now we move on to our proposed system. The following diagram shows the overall architecture of our application for sentiment prediction of stock based on financial news using NLP. First, the user lands on the dashboard and selects the stock and time frame for analysis. The parameters are passed to the backend where data is extracted from the database and returned to the user. The data is majorly a confidence value as calculated from the analysis done by calculating sentiment value of the news through our proposed NLP model. This data is displayed in a graphical manner for easy interpretation by the user. We have a dedicated pipeline that is used to extract financial news data from specific news sources using News API. This extracted data is pre-processed and cleaned to remove irrelevant information using BERT method, followed by tokenization and vectorization. This pre-processed data is passed through sentiment prediction model, which uses the encoded word embeddings generated by BERT and the LSTM model to predict sentiment. The predicted sentiment scores are stored in the database along with the corresponding news articles and their timestamps, which are helpful in finding the confidence value. The following slide shows about the structure of BERT. BERT, bidirectional encoder representation from transformers, is a pre-trained language model developed in Google in 2018. It is a transformer-based architecture that is trained on large amounts of text data and can be fine-tuned for various NLP tasks, including sentiment analysis. In our project, we have used the pre-trained BERT to generate contextualized word embeddings. The model consists of two subnets, a self-attention layer to capture the dependencies and relationships, and a feed-forward layer that generates features that are useful for various NLP tasks, each followed by residual connection and a normalization layer. The next slide shows on the LSTM structure, that is a type of a recurrent neural network that is commonly used for the sequence modeling task, including sentiment analysis. LSTM is designed to overcome the vanishing gradient problem that can occur in a traditional RNN when training on long sequence of data. The LSTM structure contains three gates: forget, input, and output gate. Forget gate decides which information to retain and which is to be discarded. The input gate determines how much new information is added to the memory cell, and output gate determines how much information is passed on to the next step. Next slide gives a classic example of how a news is basically fit into a LSTM model, wherein the pre-processed news basically is passed to other models such as RNN LSTM, RNN GRU, and NaveBase, all of which are trained on the same dataset. Based on the results presented in the table, the output generated by the bidirectional LSTM model is found to be identical to the expected results, which is not the case of other models, wherein the RNN LSTM fails in first and third scenario, and RNN GRU and NaveBase fails in second and third scenario. The next slide gives us an accuracy chart of all the models which we have trained with bidirectional LSTM model when trained and the data pre-processed with BERT technology gives an highest accuracy of 90.1%, which is 0.901, followed by RNN LSTM with 89% and RNN GRU with 89.4%. And last being NaveBase with 53%. So now I have Pratima, one of my co-author, who will discuss on the tech stack and the salient features for the application.
Yeah, thank you, Kushal. So we discussed the salient features of our application now. Impact of stock sentiment based on news, previous stock movements, and investors' sentiment. It is trained on daily Indian financial news from 2000. Provides unique pre-processing method using vectorization and normalization and BERT data processing technology. Users can view positive and negative news counts. Users can view a main confidence value for a given number of news of a specific stock company. Next, coming to the tech stack, we have used React.js. It is a framework used for programming frontend to the web application. Then we have used Material UI, which is a NPM library that has a bunch of React components like date picker cards, select element, which were used in our application. We have used Flask, which is used for programming the backend, that is creating REST API. And then we have used TensorFlow for machine learning. It facilitates by providing models like RNN and STM. We have used ngrok to host our server. Next, uh, coming to the implementation screenshot. This is our homepage, which contains financial news of 5 different companies along with a confidence value, which could be positive, indicating the news is probably positive, and negative, indicating the news is probably negative. Users can also read the full news. Next. Users can set a time range to filter out the news. For example, we select 8 July 2022 as start date. Next. And 21st July 2022 as the end date. So therefore, we must receive the news to view a mean confidence of a specific company. The user might want to select from a bunch of provided options. Say we go with HDFC Bank. So the user will now be taken to the stock specific page where the news for that particular time range would be displayed. Scrolling down a bit next, scrolling down a bit, users would be able to view a bar graph which distinctly shows the count of positive and negative news. To the right, a God chart can be viewed that will always range from -1 to +1, which implies the nature of the stock from a mean confidence value indicated on the chart. -1 meaning completely negative and +1 meaning completely positive. Here we can see that the mean confidence is 0.32, which implies that the nature of the stock is positive by 32%. This next. The authors for the same are Kushal Shah, Joy Almeida, Pratima Singh, and our guide and mentor has been Rupali Sam. We are happy to take any questions.